Okay, so the idea today is to give a high level overview of AI solutions. But first, I want to give an overview of AI. And I know many of you probably already know these concepts, but I guess, it's a good idea to review them, make sure that we're all on the same page. So, let's go ahead and, also talk a little bit about what kind of AI we are talking about. So AI really is nothing new. It's been around for more than 50 years. However, there's some specific areas of AI that really have developed a lot in the last couple of years. So AI involves, different things. So for example, you could have expert systems that we used in the past that are still in use where, developers coded the knowledge in the code. So that's not really AI from what we understand today, but it was AI back then. So the developer was going to code the knowledge into the code. However, what we see today and what we've been really talking about is machine learning. So this is the area AI has been growing exponentially in the last couple of years. And the big difference is that the system is going to learn by experience or data. So instead of telling the system what to do, you show the data and the system is going to learn by itself. So that's the big difference. And there we can find many different usages that can be done, like prediction, natural vision processing. You have different types of algorithms, simple ones like decision trees even. It's a very simple thing that they learn with data and more information. Then you have, linear regressions that are also very popular as well. Neural networks that are being used in many cases. So, here's when we are talking about AI. We will be focusing on machine learning. So let's go to one simple example, just to see what we mean, by learning by data. So let's suppose that we need to calculate the emissions of a car. We could go and write something like this. It's going to tell how to calculate the emissions based on the engine volume and the car weight. So we could write a formula, and I just put the simple one here, but you could of course make it more complex, and then come up with a formula that is going to give you the emissions. So we're telling the computer how to do it, essentially. But there is another way, which is actually telling the computer, okay, here's the car, this is the volume, this is the weight, and this is the emissions. And, give the computer a lot of information about that. And then by looking, at the data, the computer is going to learn it's going to learn how to calculate or predict, that's a better word, or how to predict the emissions based on the volume and weight. So here in that slide, we have a link, and that really is a nice example. So here you have the list of cars with, the volume, weight, and emissions. And then if you scroll down, there is one example that is written in Python. So basically, it's going to read that data set, and it's going to indicate which are the X, which are called usually in AI, they are called features, and what is the output. So in this case, the emissions. So you can see how you're reading the file. Then we are training, where we would say, we're training the model, so it's going to do a linear regression, which is a very common algorithm for AI. And then once it's trained, you can predict what's going to be the emissions. So in this case, If I run this, it's going to give me a number. And in this case, we never told the computer how to calculate the emissions. We just gave the computer data, okay? And the computer learned how to calculate and to predict emissions. So that's the basic about AI. And now if we go back to the slides here, we'll see a little bit more complex examples. But everything comes from this very simple concepts of learning from data. So you can see we have the features, then we have the model that is learned by data, and then we have the output. So this is not a linear regression. This is a neural network, but it doesn't really matter. There is a model in the middle that is learned by the data. If we take the same simple concept to a more complex use case, let's say we want to detect a cat in a picture. So we can have a picture and decompose that picture, into numbers for red, green, and blue, and then we can put that into a vector of data. And these are just numbers like the two variables. That we had before, so x1 and x2, but now we have many features. So each of them is going to be one of the numbers in here. So the concepts remain the same, but as you can see, it's much more data. That's why AI has exploded. So in the last couple of years, because we now have the computer power to process all this information that we didn't have before. So, these are going to be the inputs. If we provide the model with enough images of cats, the model is going to learn to detect if this is a cat or not. So basically, when you provide the information, these layers in the middle saying that you'll have many more features here, that you'll have many more layers, and then they'll just be adjusting by training when you provide the images. So all these layers, all these boxes are being adjusted by the training that you provide, and that's going to help to get the output at the end. So the concepts remain the same, and then you keep making things more complicated. So let's suppose we want to detect a cat in an image. Now, we don't want just to take if the image is of a cat or not, but we want to see if we can find a cat in an image and find out where it is. So, again, it's the same similar concept, but you start mixing things. So maybe first try to, you put in the size, you try to put in the box in here, and you find if it's a cat. No cat there. Then you can find a cat, and then you take this piece of the image. Okay, and you go through the same algorithm that we were describing earlier. Before, you don't have a cat. You do it here. You don't have a cat here. This doesn't look like a cat. But then you finally get here, and you get this image, and you get this image to this through the same algorithms, and well, we got a cat. And we can say, here, we have a cat. So of course, today's algorithms, they're going to detect objects much more efficiently, but that's something that can be done and was used at some point. So you can see how we have a very basic thing we got started here. We can end up something like this. And then to see another use case for example LLMs, so how they basically work is you provide a text and they will create tokens for it, different pieces. So then the text and tokens, they're not really words, but just a couple of characters, really. Sometimes, in some cases, just one even. But the idea is that you split the words into tokens, and they do some transformation to make it more efficient. But then, well, basically you end up with a vector. So this is basically the same vector that we're seeing here, right? So the same vector that we have here ends up with that vector here. All the features you go through, well, basically neural networks or any other kind of model, and then you predict the next token, and you have the next token here, and then you have another vector, and you can predict another token. So that's how you generate text using AI. And again, if we go back, everything comes from here. So from that basic concept, we can generate text and, even better, make it look like it is smart, essentially. So this is the basics about AI. And of course, when we work with AI, we don't really need today to think about all these things, really. So what happens in the solution space, really, from all the problems of the universe with imperative programming, I'm finding it imperative programming because that's the most common way of programming, where we tell the computer what to do, we could solve its set of problems. But now with AI, that set of problems, that can be solved. It's much bigger. So it's just much more bigger. We have more opportunities. So it's important that when we look at the problem, today, we not only think about what we could do with, say, traditional programming, but we need to incorporate the tools of AI and think, when we look at the problem, what can be solved with it, with traditional programming, and what can be solved with AI. And we'll find that there are things that now we can do that before was impossible to do. So I have just a few cases. I don't know if you're old enough to remember, but basically those silly programs that we were trying to emulate conversations with the computer. They're very stupid, let's just say stupid bots, and they were trying to detect words based on some words. We're making some answers and responses. So it was impossible to code that, okay? So we just don't have the capacity. We just didn't have the capacity as humans to code something like that, to tell the computer what to do. So it was a problem that was intractable, basically. So it had really no solution. In terms of recognizing our face, it was that not possible to solve with programming. So this is another problem where we were basically stuck. And of course, there were other AI algorithms, but it was very hard to do translation. There were like a lot of translation systems that were trying to take into account a lot of conditions, but it was never enough. So here's where I can start solving those types of problems that before it just was, it wasn't possible. So programming is really good for deterministic problems where you know what needs to happen, what's the process to get the output. So for that, there is nothing better than traditional programming. Actually, if you try to use AI to solve those problems, it's going to be very inefficient and probably not very reliable. So if you can solve it with traditional programming, you should do it. But AI is better for probabilistic problems where things are a little bit faster. So this picture of this person, basically, probably I have a 95% chance probability that it is. So it's nothing 1 + 1 = 2. Well, it doesn't work like that. It's more like there are probabilities that it's like that or not, but it gives you the power to solve much more complex problems. So there's another way, the reason why AI has become very popular. So after ChatGPT, for instance, I would say if I had to put, like at a point in time, it's that we started having these foundational models, ChatGPT, Gemini, Meta AI. So these are the models that have been trained with massive data, text, images, audio, videos. So we don't have to start from scratch, basically. So that's the beauty of these foundational models, okay? So we don't have to, there's a lot of work we can leverage when we need to create a solution that uses AI. So we can use it for different tasks that we would have to do them, without a foundational model. It's a lot of work. Without a foundational model, it's a lot of work. So for example, let's take the sentiment analysis, which is very popular in some AI services for that. So before these foundational models, you had to go to find thousands and thousands of examples. This for text, and maybe this one is for the person that's angry. For this one is happy. So you have to do a lot of label data, is what it's called, essentially, in order to figure out what the mood was of the sentiment. So now, with an LLM, you can basically just write a prompt and you can get it done. So it's something that used to take, I don't know, used to take weeks, months, probably collecting data, writing a pipeline to standardize data, train the model, find the model, train it, test it, and iterate the model to get good results. Now it only takes a couple of minutes, maybe more if you want to evaluate and do things the right way, but still it's a huge improvement. So that's why these foundational models reduces the cost so dramatically. And then, basically on the other side, even though these foundational models can be used as the basis to solve different problems, they're not adapted to specific problems for a business. So they still need to be adapted basically to each specific task of the needs that a business might have. And this is where we can apply AI we have with these models. The other day we were talking with a potential customer that they were trying to use AI, but basically they gave up because of hallucinations, and the results just they weren't reliable. And basically the problem is that they were not adjusting, they were not fine tuning the models or what they needed. So a specific task they wanted to solve. So even though they were very useful, you need to adjust them to solve a specific problem. So you need to provide more context. You need to fine tune. There are different techniques so you can get a good performance in these AI solutions. So how to apply? Big question. How to apply? So I guess AI is not going to do everything. Instead, we need to identify which are the tasks that need to be solved with AI. So first of all, we need to make sure that we break down the business process into tasks. So that's going to help us identify, okay, which of these steps can be done using AI. But before, thinking on that, we need to see what can be automated using traditional programming. As I was saying before, it really just makes no sense trying to solve something using AI if you can solve it using traditional programming. It's going to be more reliable, it's going to be faster, efficient. So you shouldn't do it if you can resolve it with traditional programming, except there are some cases, maybe you can do it with traditional programming, but it's going to take more time to figure out which is the algorithm. Maybe with AI you can do it very quickly, but if it's easier to solve with traditional programming, you should go ahead and use traditional programming. And then from what's left, you can start thinking and identifying which things can be solved using AI. So I got this here. So here are a few examples from things that we have done and we've been, analyzing. So one project that we have been analyzing the summarization of medical records. So there is a doctor that needs to present the medical records of patients, in the court for a legal case. And they have to provide a summary with the most important information of a patient to the judge. So something along those lines. But this process has several steps. So like gathering the records of the patient, sending the documents by email to another firm that is going to summarize those records. They have to read, they have to go through all the information and summarize each appointment that those patients had, in the past. Then they will create, a draft version of the summary. Then they will send it to a doctor. The doctor is going to review and make the changes that are needed. And finally, they're going to sign, and they're going to sign the final version. So this is the process today. So, if we look at, all those places where we can automate using regular programming, like sending documents by email so we can gather and send the documents, we can create a draft version, as it were. So it's just filling the placeholders, creating a document, send it to a doctor. The doctor is going to provide some signing software to sign the version and send it by email. There are things that the doctor still will need to review manually, so this step is going to remain manual for that reason. And then we're going to probably improve with AI. So make a record of patients, and actually, I put in a sentence soon there, but it's AI is going to summarize the medical records essentially. So let's take a deep dive into each one of those steps. So by gathering the medical records, I mean reading the PDF file. So in many cases, we will need AI because they contain images instead of text. So we need to be able to detect the characters and what's the text. Also, we need to split the appointment. So sometimes you're having a PDF, several appointments with different structure. So we need to be able to split the document with appointments using an LLM. Then we need to extract the information about who is the doctor, the date, and things like that. And that's not always in the same place, or it's hard to parse that with a script, basically. So it's easier to ask the LLM to extract that information. Then if we go to the summarization, well, in this case, we will have a lot of information, and that's already done. So we can fine-tune the LLM with summaries that already exist to teach the model. So to fine-tune an existing foundational model to work better on these use cases, so we can pass the appointment and get right to the summary. So, once the doctor approves the summary, we can use that information for further fine-tuning or maybe using a RAG. So we're going to talk more about that in the next Tech Talk. But here we can identify which steps can be done using AI. So not everything is going to be solved using AI. It's not going to do everything magically. We need to find the tasks that we understand AI is going to apply to and work on that problem specifically. So yeah, there's really another use case where also, sometimes it's the process is going to change. So another project that we've been discussing is the dumpster project, where it's a company that delivers containers to construction sites. So then when the container's full of waste, they have to go and pick it up. They have to, empty the container. They have to review it if there is any contamination in it. So if there is contamination in the container, they cannot empty the container, just anywhere. They need to take it to one special place and things like that. So the process today is they deliver the container. When the container is full, the customer is going to request the pickup. Then they're going to schedule the pickup for the following days, and they'll need to check if there's any contamination. in the container to decide where to take the waste, dispatch the waste, and then send the container back to the construction site. So in gross strokes or in big scopes, that's the process today. So we're going to be talking about using AI to improve this process. So in this case, look at adding just one thing with AI was improving the overall process. So what they were thinking, is adding cameras to the containers. So with that, it's going to be taking pictures. So that way we can check the fullness and also the contamination. So you're looking at the time so you can identify the contamination in the container and how full it is. So that way we can schedule the pickup of the container in advance, and we also know the road because whether it has contamination or not, and then we know where we need to go, and then we can dispatch the waste and send the container back to the construction. So by using AI, we can optimize the whole process. So it's not just we automate the steps that we have, but also we can optimize the whole process. So again, it's about having a business process. It's to break it down into tasks and figure out what can be automated with AI. And I think that's going to make it much easier to think on solutions instead of trying to see if AI like that is something is going to solve everything. If we can start with small things, we can automate more and more. And maybe at some point it will do everything. It will do our job, and so on. Well, that was it for today. It was a short presentation. So the idea is to, talk things more generic about, AI. And then in the next Tech Talk, I'd really like to do a deep dive into the more technical aspects. So thank you very much, and we'll see you next in the next Tech Talk. Thank you so much. Bye-bye.